Hello, my name is Donggun Yoon, a PhD student at KAIST AI, and today I'll be presenting a paper called LangBridge Multilingual Reasoning Without Multilingual Supervision. So the TLDR of this paper is that LLMs specialized in reasoning are mostly English-centric. So for example, MetaMath is based on Llama 2 and is fine-tuned on mathematical reasoning dataset, and Orca 2 is based on Llama 2 as well, and is fine-tuned on COT generated by GPT-4 and is able to solve complex logical reasoning dataset, reasoning tasks using the high-quality COT. Now we want to adapt these models to solve multilingual tasks as well, but let's try that without using any multilingual data. Now this is a brief overview of our method. So first you would need a multilingual encoder. In this paper we used MT5 encoder because it supports a wider range of parameter sizes, and it also supports longer context lengths compared to other encoder models. And then you would basically connect the multilingual encoder model to the target language model that you want to adapt using a single linear layer. And you would align these two modules using an English in-domain dataset. Now, when I say in-domain dataset, I mean a dataset that resembles the fine-tuning or pre-training data of the target language model. So for Orca 2, we used a dataset called OpenOrca, which is an open source replication of the Orca 2 or Orca 1 dataset because the dataset was not open sourced. Now, after these two modules are aligned, you can test the model in using non-English input, and it's able to solve reasoning tasks that's basically in languages that's basically supported by the multilingual encoder. Yeah, all in all, we are able to adapt the target language model to multiple different languages without using any multilingual data. Hence the paper title, Multilingual Reasoning Without Multilingual Supervision. Now I'll explain the motivation of this paper. Now, what people commonly do to adapt English-centric LLMs to other languages is to continually train in the target languages. But this approach is quite challenging to scale to a large number of languages, so like hundreds of languages. And especially this is the case for models such as MetaMath or Orca 2, because these models are trained using a specialized training dataset, which are not available in any other languages. So you would need to like construct the training dataset in other languages to basically apply this approach to these models. Now, maybe just a handful of languages, it might be possible, but uh, doing that for like hundreds of different languages is quite infeasible. Now, LangBridge avoids this issue by not requiring multilingual data while potentially generalizing to the large scale of languages included in the pre-training of the encoder. Now let's talk about some related work, and the first part is pretty obvious. A lot of the open source models that are good at reasoning, like I said before, are English-centric. So for example, MetaMath is based on Llama 2 and is trained on this MetaMath QA that they created for this model, which is also obviously in English, and the resulting model is very English-centric. Another core concept of this paper is the concept of zero-shot cross-lingual transfer. What it basically is that the multilingual LLMs can solve tasks in multiple languages after being fine-tuned on high resource languages. So think about multilingual BERT. So to create multilingual BERT, first you would need to pre-train the model in unlabeled data across multiple different languages, right? But then you would need to fine-tune the BERT model to use it in a specific task. So in this example, they are showing sentiment analysis. But what's really interesting about multilingual models is that despite being fine-tuned on, let's say, English, it's able to solve the exact same task, the sentiment analysis, in many different languages that was included in the first stage of the pre-training. Now, this is a very important and profound concept because a lot of the time, fine-tuning data is only available in a select few languages. And so, for example, if you want to do, sentiment analysis or whatever in a very low risk languages, more often than not, you won't find a data set in that languages. So what you can do instead is use a multilingual model and train that task using English data, and then just infer using the original language that you wanted to use. Yep, that really enables like a lot of different languages to do a task that it wasn't able to do before. So why does zero-shot cross-lingual transfer work? In short, it's because uh, the language agnostic nature of multilingual LMs. So the representation would look something like this, the D in this plot, where different languages are kind of, mapped together. And if you fine tune this model in a certain language, the representation move together between languages. So therefore, you can, in test time, use the model that in a language that it wasn't fine tuned on. Now finally, related work, aligning pre-trained representation. This is, I think, pretty, you'll be familiar with it. It's mostly commonly used in VLMs, where you would align a pre-trained image encoder with a language model to acquire visual understanding of the language model. Now, LangBridge architecture is quite similar to the Lava model, where they use a single linear layer to connect the encoder and the model. But one key important detail that differentiates Lava from LangBridge is that these cross-model alignment requires some sort of cross-model data. So it's commonly they use image captioning dataset to acquire, image to text mappings. But unlike these cross-model alignment, language does not use multilingual data. So it only uses English data to acquire multilingual understanding, whereas, like I said before, VLMs use cross-model uh, data to acquire cross-model modality understanding. Um, yeah, so this is the evaluation result. Um, if you apply LangBridge to MetaMath 7B, as you can see, the underrepresented language performance boost is very significant. Before the original model is the performance degradation when it comes to underrepresented language is very substantial, but the language model is the difference is quite reduced. Now, we do acknowledge that applying LangBridge to a certain model may degrade the high result language performance as is seen in MetaMath 13b. But all in all, overall, the average performance boost is very, very significant. Yeah, other than this, we also evaluate on code completion, logical reasoning, and common sense reasoning. We also evaluate on many different models. Yeah, so why does LangBridge work? So, the reason is because representation of multilingual encoder models are language agnostic. So if you apply PCA to Orca 27B, the higher languages are kind of clumped together. So English, Spanish, German are kind of somewhat close to each other, but lower languages like Telugu and Swahili are very distant from this high resource cluster. But if we apply PCA to Orca to LangBridge 9B, all the five languages are kind of clumped into a single cluster. One thing to note is that Swahili is written in a Latin script, so it's definitely not the script's issue. It's just that the representation in the original base model is just so different across high resource and low resource languages. But yeah, LangBridge is able to mitigate that. One other thing to note is that the scale of these two subplots are different. So while this cluster looks kind of big, if you just compare it to the subplot above, it's actually quite small. Another interesting detail is accidental translations by the language models. So accidental translation is when the language model confuses the input language. So for example, this is a task on Big Bench Hard. It's given in Bengali, but Orca 2 LangBridge 9B model actually perceives this input as Chinese. And as you can see in the COT, it actually recites the given options in Chinese, thinking that it's originally written in Chinese rather than Bengali. Now, something like this isn't really common, and it's quite actually rare for a language model, but it does exist, and it kind of hints that the language model is perceiving different languages similarly. Okay, like I said before, we also did tests on many different models, and you can check these models out at this QR code. Yeah, thank you very much for listening. Bye.